Okay, so I decided to just do a quick video on going over the first two FRQs because I want to spend some time in class just keeping the time for the multiple choice questions. Okay, so this question is relatively easy, and the second question is actually a really good review of a lot of the electrochem concepts. So I'm just gonna go over them, and you guys can watch it. All right, so um, I'm gonna use. Okay, so the question is asking you to predict the sign of the entropy change delta S standard for the reaction. Anytime you get a reaction and you have to look at the change in entropy, look at the states of matter, and that will help you figure out if the change in entropy is positive or negative for that reaction. Okay, so we're going from 3 moles of solid silver and 4 moles of aqueous nitric acid to 3 moles of silver nitrate, and there's a mole of nitrogen monoxide gas, and that means the entropy change is in fact positive for this reaction. Okay, so we're going to say delta S standard is positive for this reaction because you're going from no moles of gas to 1 moles of gas. Anytime gaseous reactants are, or gaseous products are present, that contains the most entropy. Okay, so it's a positive change. Then it says to use the information in the table to calculate the value of delta H. So this is just products minus reactants. Okay, so your calculation should be delta H standard for the reaction is equal to 3 times the, let's see, silver nitrate is negative 101 plus 1 times the 90 plus 2 times the 200, negative 286 minus now your reactants. Now silver, there is no number given for silver, but that is okay because silver solid is in its standard state, and elements in their standard states have a delta H formation of 0. Okay, so you don't need silver. All you have to do is do 4 times the negative 207, and that should give you 43 kilojoules per mole for this reaction. Okay, make sure to include units in your answer because that's super important. All right, then based on your answers to parts A and B, is the reaction more likely to be thermodynamically favorable at 25 degrees or at 95 degrees? So this reaction is endothermic, right? So it requires the input of thermal energy, more thermal energy than is released when products are formed. However, the delta S is positive. So if you have a positive delta H and also a positive delta S, that means at a higher temperature in your reaction or your equation for delta G is equal to delta H minus T delta S, this term is going to be more positive, right? So because of that, you will end up with something that is more thermodynamically favorable at a higher T value. Okay, so delta S is positive here, so this increasing the temperature is going to make this reaction more favorable. So it is more favorable at 95 degrees Celsius because of the fact that delta H is positive, but delta S is also positive, and that will increase this term. Okay, the student runs the reaction using a 3 to 4 mole ratio of silver to nitric acid. Suggest a method the student can use to isolate solid silver nitrate from the other products of the reaction. So the 3 to 4, like none of this matters. Okay, you are looking at just your products. You have a gaseous product which is just going to bubble out of your aqueous solution, and the silver nitrate will be dissolved in water. That is why it's aqueous, right? So if you have water as one of your products, the easiest way to get rid of water to leave a ionic compound that is collectible is just to evaporate the water. So evaporate the water and obtain dry AgNO3. So think of it this way. AgNO3 is just like any other ionic compound, table salt. If you have a salt water solution, if you let the water evaporate, you're left with salt. Therefore, you can just evaporate the water and you're left with silver nitrate.